second lesson in grade 9 probability is about compound events. And this is really the topic that's new in grade 9 and that we focus on in exams and tests. So what is a compound event? A compound event is two or more simple events. So as an example, drawing two cards now instead of one. This is a compound event. Rolling two dice, where before in our last lesson we only rolled one dice. You could have flipping a coin and then rolling a die, two events. So we have two different ways to visualize all the possible outcomes of a compound event. You either have tree diagrams or we have two-way tables. So we're going to go through both of these examples. In our first example, let's look at a very simple one where two coins are tossed. So the first thing we want to do is draw a tree diagram to represent all the possible outcomes. Well, let's look at what happens. If we toss our first coin, this is our first event, and we have two possible outcomes. We can either get heads or we can get tails. After we flip that coin, we flip our second coin. So if we get heads on the first flip, let's highlight that. If we get heads on the first flip, then we can still get two possible outcomes on the second flip, and those are either heads or tails again. Let's say instead that we got tails on our first flip. Now we're going to flip again, and we still have two possible outcomes of heads or tails. So we can see the tree diagram shows us different possibilities depending what happens in the first event. When you draw a tree diagram, it's very important to list your outcomes. So I even like to sometimes draw a little line here so that I can separate all the different outcomes. So what I've done, this first outcome says HH. So I follow along this line. I have H and H, and so this first outcome is heads, heads. The first outcome is heads, heads. And carrying on, I have H, my first outcome H, and then T. So the next outcome I would list would be heads, then tails. And I carry on writing out the different outcomes and following the tree. My last outcome will be tails, tails. So I can see that if I count these up, I have 1, 2, 3, 4 possible outcomes in total. Those make up my sample space. And then we can answer this question. What is the probability of both coins flipping heads? So let's look at the outcome where both of the coins are heads is this one out of 4 possibilities in total. So my probability is 1 out of 4. Let's look at the same example, except now we're going to show these outcomes using what we call a two-way table. So this is just another way of visualizing the sample space of all the different outcomes. In a two-way table, our rows going down the page, so our rows represent the first event. So I have my two outcomes. I could have heads or I could have tails. The columns represent my second event. So in this case, that's the flipping of the second coin, and it has two outcomes of heads or tails. So the way that we work this is that we take the first event and we marry it with the second one. So I have heads and heads. And carrying on across to the right, I have in my first coin heads and my second one tails. Then filling in the table, I then have tails, then heads, and then tails, tails. So these 4 represent my sample space. Just like before, these are the same exact outcomes as when we did the tree diagram. And I can use these to answer the question, what is the probability of not flipping two tails? So let's count our outcomes. So I want everything that's not two tails. So I have 1, 2, 3 outcomes that are not two tails out of 4 possible outcomes. So I get 3 out of 4 as my probability. This is a slightly more complicated example with a two-way table. Sonia spins an arrow on a spinner, and the spinner has the colors red, blue, yellow, as in the diagram. She then rolls a die. She records all the possible outcomes in the two-way table that I've shown here. So the first step is we need to complete the table. Like I said before, you take the row first. So in this case, red, we've abbreviated with R, and then you marry it with the number in the column. So we should have R3, and carrying on across, we have R4, red 5, and red 6. Now going down, I'm now on the blue row. So I have blue 1, blue 2, and on and on. And so I think you get the idea of what we're doing here. We can complete the table, and we now can see our entire sample space. Let's highlight the sample space. The sample space includes all of our possible outcomes. Okay, so now we're going to look at these outcomes to answer these questions. How many possible outcomes are there? So if I count them, I see I have 6 going across by 3. So if I counted them up, I would get 18. So there are 18 possible outcomes here. The probability of getting Y3, so that's yellow and 3, I only have one outcome that's yellow and 3, so my probability has to be 1 out of 18 possibilities. Okay. Let's erase that. All right. The probability of getting a result containing the color blue. So the color blue, I see I have 1, 2, 3, 4, 5, 6 outcomes where there are blue out of 18 total, and that simplifies to 1 over 3. The probability of getting a result containing the number 5. So delete these tick marks. All right, so the number 5 is seen. Oops. Okay. So let me do my ticks. The number 5 is in 3 possible outcomes, so we can see the answer there, 3 out of 18, which simplifies to 1 over 6. 3.6, what's the probability of getting a result containing red and an odd number? So let's tick all the ones that are red and odd. So red and 1, 3, and 5. So I have 3 possible outcomes out of 18 total. Again, that simplifies to 1 over 6. And what's the probability of getting a result containing blue or yellow? So blue or yellow. That means that we want to tick everything that has blue or yellow. All right. So blue or yellow could be either of those. So I've ticked 12 boxes out of 18 total possibilities, which is 2 out of 3. All right, here's another example that we see often. In a restaurant, you have your meal served with a choice of chicken, lasagna, or mutton curry with a side of salad, spinach, or roast veg. Use a two-way table to show the possible outcomes. So, sorry, this example might make you a little bit hungry. We have a choice of mains, and then with that, we have a choice of sides. So the first event is the mains, and the second event is the sides. So mains and sides. Okay, So each of those is going to go on one side of our two-way table, and then I've listed all the options. Now we have to be careful because we're not going to write out, I mean, you could write out the full words, but I'm going to abbreviate. But you have to be careful because both salad and spinach start with S. So I need to be a little bit more specific. Watch what I do here. Chicken and salad. So I've said SAL, but you could just do SA. I could get chicken and spinach. I could get chicken and roasted veg. Lasagna and salad. Lasagna, spinach, lasagna, roasted veg. And you get the picture. So I now have my entire sample space filled out. Let's highlight our sample space. And we can see that there are 9 possibilities. So my sample space is 9. And I can answer the question, what's the probability of choosing chicken? Chicken is in 3 of the outcomes. So my probability 3 out of 9 or 1 out of 3. What's the probability of choosing lasagna with salad? So that means lasagna and salad. There's only one outcome that has lasagna and salad out of the 9. So my probability is 1 over 9. And the probability of choosing mutton curry with salad or spinach. So I need to look at all these options that have mutton curry with either salad or spinach. So that's this one and this one. I've ticked 2 boxes out of the 9 possibilities.